Okay, I believe I got it. Hopefully that this works. I'm actually gonna get rid of this camera since it doesn't matter. Okay, we're talking about still the X and Y intercept. But now instead of having or looking at the graph, we're going to be looking at equations. We could still do the same thing with equations. This is just basically a geometric way of looking at it, and this is uh, algebraic way of looking at it. I forgot, I lost the words. Um, but yeah, first we did the graphs, and now we're doing equations. I'm not going to be doing these equations. I'm going to be doing similar. The ideas are still the same. Okay, let's see. Again, we're finding the X and Y intercept. I'm just going to write at the top. We know if we want to find the X-intercept, we have to set Y is equal to 0. We need to set, okay, need, um, yeah, Y is equal to 0. There you go, that's how I want it, right? And then if we want to find the Y-intercept, which is going to be 0, comma, whatever your Y value is, you need to set X is equal to 0. And what I mean by set, it just basically it means another way of saying let. It's another way of saying it. It's like, oh, let X equal 0. Let Y equal 0. It's the same thing. Okay, so this is how we basically need to figure it out for these equations. I'm not going to be doing these equations. Let's just make up equations right now. Okay, let's do 5x plus 3y. Try to make it look very similar. Okay. We need to figure out what is a y-intercept and x-intercept. Let's just do the x-intercept first. Again, we need to figure out, we need to set y is equal to 0. So every time whenever you see a y, you set it equal to 0. I'm just going to, this is going to be for x-intercept, for y-intercept. I'm just going to do 2 lines. I'm going to space out my work. Now, okay, let's see. For the y, or the x-intercept, we have to set y is equal to 0. So we need to, every time whenever we see, or for this equation, every time whenever we see a y, we have to replace it with a 0. So we have 5x, there's no y yet, 3y. What do we have to do? Set y equal to 0. So we saw that 3, and we set y is 0. We just replace the y with a 0. And copy equals 12. We copy the exact same equation. All we did was just replace y with 0. We set y equals to 0. That's all we did. Now we have 5x. We didn't change anything there. What is 3 times 0? It is 0. And 5x plus 0 is just still 5x. Now we have one thing to do. We need to solve for x. 5x equals 12. How do we get rid of, or how do we get x by itself? Well, well, since it's 5, another way of saying 5x is 5 times x. how do we get, or what's the opposite of multiplication? Division. We have to divide by the number in front of the x, which is a 5, so we divide by 5. Divide by 5 on both sides. The reason why we're doing this is because 5 divided by 5 is 1, which cancels us out. Or, yeah, that's it. So it's just going to be 1, and then it's just going to be 1x, which is just x. So we got 12 fifths. So when we set y is equal to 0, we get x is equal to 12 fifths. Now, how do we write it in our points? Let me actually write down all the points are going to be x, comma, y. That's how you write down your points. So we know what our y value is, which is y is equal to 0. So we put 0 for here, and then we know what our x value is 12 fifths. So I'm just going to write it down over here. 12 fifths, comma, 0. This is our x-intercept. Now for here, let's do the y-intercept. Now what do we need to do? We need to set or let x equal to 0. So every time whenever we see an x, we replace x with a 0. So 5x, so we have to replace this x with a 0. 3y, leave everything by itself. All we're doing is letting, I'm just going to write down let. Yeah, let's do that. Let x equal 0. So that's what we did. We let x equal to 0. Same thing. That's what that's how we find our y-intercept. Now, what is 5 times 0? It is 0. We didn't do anything over here, so we just keep the same thing. Now, what is 0 plus 3y? Well, it's just 3y. Same thing over here. We want to get y by itself. How do we get y by itself? We need to solve for it. Since this is 3 times y, what's the opposite of multiplication? Division. Why did I choose 3? Well, the reason why I chose 3 is because I want to cancel this number out. We want to cancel 3y, or no, we want to cancel 3. So how do we cancel 3? Divide by 3, because it's multiplied by y. So this is going to be 1. So this is just going to be 1y, which is just y. Well, whatever you do to one side, you have to do it to the other side. What is 12 or divide by 3? Well, 12 divided by 3 is just 4. So y is equal to 4. So what is our x? Our x is 0. Our y is 4. So how do we write it in our point? Or how do we write it in the point form? It's x comma y. X is 0. Y is 4. So this is our x-intercept and our y-intercept for this equation. So when we do our like little graph, that's actually bad. It's actually going the other way. Whoops. We're gonna have a x or y-intercept here, and then this is 1, 2, somewhere like right here. So this is our x-intercept, and this is our y-intercept. It's just like a rough picture, but it's gonna look like that. Just for a visual representation on how because that's what we did on the other problem, or on the other graphs. Okay, let's do another one. Let's do that. Same idea. We want to find the x-intercept, the y-intercept. What do we need to do for the x-intercept? We need to set or let y equals 0. Just like how we did the other problem. Exactly, that we follow these rules. Whenever we want to find the x-intercept, let y equal to 0. Just like this. So, this is our equation. Okay, let y equal to 0. 10x plus 2y, but what is our y? 0. We didn't do anything to the 7, and just keep it the same. Now, what is, we didn't do anything to the 10x. Now, what is 2 times 0? Just 0. I'm just going to save a step. I'm just going to skip that step. It's 0. And we didn't do anything to the 7. Just bring it down. This cancels out. It's just a 0, if that makes sense. Now we have 10x equals 7. Now, how do we get x by itself? We need to get rid of this 10 in front. We want a 1 in front. How do we get rid of it? We have to divide, but not just any number. We can't just divide it. Well, we can divide any number, but we want a 1 in the front. How do we cancel the 10? Well, we have to divide by a 10. That's how we get a 1, because anything over the same thing is a 1. It's just a fancy 1. Like I could do 1 million or 100 trillion or whatever, and then the same number, 100 trillion, is always 1. It's just a fancy way of saying that. That's what we need to. That's why we need to get a 1 in front, so we can get x by itself. We want 1x. Whatever we do to one side, you have to do to the other side. So we got x equals 7/10. That's it. So we need to write it in our point. Remember, it's x comma y. What is our x? Well, our x, we just figured that out, 7/10. Now, what is our y? Well, we told ourselves to let y equal to 0. So this is our point, 7/10, comma y. Now for the y-intercept, we do the same thing. Let x, well, not exactly the same thing, because this time we have to set x equal to 0. Another way to say set, just let x equal to 0. Just a different way of saying it. Don't be confused by the way, because I'm interchanging the way I'm saying it. It means the same thing. Let x equal to 0, set x equal to 0. It doesn't matter how you say it. All we care about is x is equal to 0. That's all that matters. Now, okay, we got 10 times x, which is 0, because that we told ourselves to put 0 every time whenever we see an x. Plus 2y, we didn't do anything to the y, is 7. Okay, 10 times 0 is just 0. This goes away. It's just 0. Now, all we're left with is 2y equals 7. How do we get y by itself? We have to get rid of the number in front. What is a number in front? It is a 2. Since this is 2y, this is another way of saying 2 times y. How do we get rid of this number? We have to divide by the same thing, which is 2. 2 divided by 2 is 1. It cancels out. That's how we get rid of it. Now, whatever we do to one side of the equation, we have to do to the other side. We have to balance it out. So we have to divide 2 on the other side. So all we're left with is y is equal to 7/2. So what is our point? Remember, our point is x comma y. What is our x? Well, our x is 0. Because that's what we told ourselves at the very beginning. X is equal to 0. What is our y? We just figured that out. It's 7/2. I hope that's good. Let's do another one. I know this is going to be kind of redundant, but I'm just going to be going faster. I'm just gonna, let's see. Okay, same thing. I'm just gonna put X for Y. Just going a little bit. I don't want to get. So, same thing. For the X-intercept, we have to let Y equal to 0, because that's how we find the X-intercept. Y is equal 0. So every time whenever we see a Y, we replace it with a 0. 20x plus 10y. Replace that y with 0, which is this. What is 10 times 0? Well, it's just 0. So all we're left with is 20x on this side, and then on this side we just have that 30 still. Now, how do we get x by itself? We have to get rid of the number in front. Now, we have to divide by the same number in front of the x. Since it's a 20, we have to divide by a 20, because why we want to do that is because we want to get a 1 in front. Anything over itself, it's just 1. So we got 1x, which is just x on this side, which is what we wanted to do. But whatever we do to one side, we have to do to the other side. Since we divided 20 on this side, we have to divide by 20 on this side, which is 30 divided by 20. If you were to simplify this, this is 3 halves. You can get rid of the zeros because there's a factor of 10 on each one. You can get rid of it. You could just punch this in the calculator if you don't believe me. Another way of saying is if you're to, actually I won't go into that, but yeah. You could put this in your calculator, or you could just leave it as 30 over 20, but I recommend you simplify it to make it. Usually you would have to simplify your answers, especially for X and Y intercepts. It makes the most sense to do that. It looks a little off when you don't. Anyways, X comma Y is your point. What is our X value? It is 3 halves. That's what we figured out. What is our Y value? We set Y is equal to 0. That's what we told ourselves at the beginning. Now for the Y-intercept, same thing. We have to let X equals 0, because that's how we did it on the other side. Whenever we want to find the Y-intercept, we need to set or let, another way of saying it, X equal to 0. So we let X is equal to 0. So every time whenever we see an X, we replace it with a 0. So I did 20x, which is 20 times 0. We didn't do anything to the Y. And there you go. Now, what is 20 times 0? Well, it's just anything times 0 is just 0. Let me just get rid of that. So all we're left with is 10y equals 30. Now, we need to solve for y. There's a 10 in front of the y. We need to get rid of that 10. How do we get rid of that 10? We have to divide by that same number, because it's 10y, which another way of saying it is 10 times y. What's the opposite of multiplication? Division. Now, we want a 1 in front. How do we get rid of it? We need to divide by 10, because 10 divided by 10 is just 1. Whatever we do to one side, we have to do to the other side. So we have to divide the right side by 10 as well, since we divided by this side by 10. All we're left with is on the left side is just y. So 30 divided by 10. You could do this on your calculator, but I'm pretty sure you can figure it out. It's just 3. So what is our point? X comma y. What is our x? We told ourselves x is equal to 0. And what is our y? 3. So this is our x-intercept. This is our y-intercept. Let's just do another one. Let's do a little bit more algebra ones. Let's do this. Slightly different. Here we go. We got more stuff on this. Excuse me, I burped. Again, the same thing. I hope you guys like this whole one shot. Okay, how do we find the x-intercept? We have to let y equal to 0, just like how we did the other problems. Same exact ideas. We always do the basically just follow. You have to understand why I'll explain why we're doing this at the end of, or when I do these problems at the end of it. But I hope you're following along. Yeah, when we want to find the x-intercept, we have to let y equal to 0. So every time, whenever we see a y, we replace it with a 0. So we got 20x plus 10y, which is 10 times 0, 40x plus 1. We didn't do anything to this side because there's no y on this side. Now, what is 10 times 0? Just 0. So we got 20x equals 40 times the quantity of x plus 1. Now, we need to do some more math on this side. We can't just solve for x like how we were doing. We need to get all the x's on one side in order to do this. Now, how do we do that? Well, let's just distribute this side. What does it mean to distribute? It basically means there's a operation that we have to do. There's usually in this format like a times some like quantity where you have to do a times x, a times y, or in this case it's x and y, and then this is a. So this is going to be a times x plus a times y, a times y. This is the exact same thing. It's just a different way of looking at it. Now, we have to do this exact same thing over here. We have 40 times x for the first part, which is 40x. 40 times 1, which is just plus 40. That's it. The reason why we put a plus is because it's a positive 1. And we didn't do anything to the left side, so we just bring it down. Same thing. We want to keep all the x's on one side. It doesn't matter which side you want to have your x is on, but you have to be consistent. I'm going to say this side, the right side, is the side that I want the x's. I'm just going to put it like a little x side. The x side. Actually, let me write it down. The x, it's going to make it look nasty. I hope it's clear. This is going to be, I'm going to be emphasizing, this is the x side. I'm just going to put a little x side, and this is going to be the number side. X side, number side. Okay. So, let's look on the left side. Do we get, can we have 20x on this side? No. We want the x's on the right side. We have to move it across. How do we move it? We have to, since this is a positive 20x, we have to do the opposite of addition. Subtraction. 20x. We minus 20x on both sides. this is going to cancel because 20x minus 20x is just 0. Now, we have to be careful. We got 40x plus 40 minus 20x. The reason why I put it right underneath these, the minus 20x under the 40x, is because these both have x's underneath. We want to group like terms. What does that mean? It means that you have to group the same things. You cannot do a 40 minus 20x and make it smaller. You can't do like, oh, it's or positive 20x like that. That's how, or, oh, that's a, oh man, I should have chose different numbers, but you can't combine these two. Only these two, because these two have x's on them. Now, what is 40x minus 20x? 20x. That's why I was like, oh, I kind of made a mistake on that, choosing the same numbers. Okay, so we can combine these numbers. Now, 40x minus 20x is 20x, a positive 20x. Now, but we're not done on this side. We're not. We still have that plus 40. We didn't do anything there. Now, are we done? No, not yet. This side is the x side. This side is the number side. We have to get all the numbers on this side. This number needs to go on the other side. How do we do that? We have to move it. How do we move it? What's the opposite of addition? Subtraction. So this is positive 40. We need to subtract 40 on this side. So I subtract 40. This is going to cancel. 40 minus 40, that's 0. But whatever we do to one side, you have to do to the other side. So what is 0 minus 40? Well, that's just negative 40. So we got 20x on this side, that's left over, and that's it. Now, are we done yet? No, we just want x by itself. There's a 20 in front of the x. This is 20x. This is another way of saying it, is 20 times x. Now, how do we get, what's the opposite of multiplication? Division. We want to divide this number with itself. Why do we want that to do that? We want a 1 in front of this x. We just want x by itself because 1x is just the same as x. Now, whatever we do to one side, you have to do to the other side. Since we divided 20 on this side, we have to divide 20 on this side. So, negative 40 divided by 20. Now, you can enter this in the calculator or do this in your head. What is, let's ignore that negative right there. But what is 40 divided by 20? You should be able to do this in your head. It's just 2. But it's a negative 40 divided by 20. There's a negative in front. So that means there's a negative in front. It's negative 2. You can type this in your calculator to just make sure. But we got x is equal to negative 2. Now, what is our point? It's x comma y. What is our x? Negative 2. What is our y? We told at the very beginning it's 0. So y is equal to 0. So our point is negative 2 comma 0. This is our x-intercept. Now for the y-intercept. Okay. And now we have to let x equal to 0 in order to find the y-intercept. Now, every time whenever we see an x, we put a 0. So we got 20x, or now we have to change it to a 0. So not 20x, now it's 20 times 0. Plus 10y, we didn't do anything over there. We didn't do anything to this 10y, there's no x. 40 times the quantity of x plus 1. But it's not just x anymore. We told ourselves we want x to be 0, which is 0 plus 1. What is 0? Actually, yeah, since we're over here. What is 0 plus 1? It's just 1, right? We still have that 40 in front. Okay, now what is 20 times 0? 20 times 0. Let me actually zoom in a little bit. Hopefully that makes it better. what is 20 times 0? It is just 0. It goes away. What's left over? Just a 10y. Now we want to get y by itself. There's a 10 in front. There's a problem. It's 10 times y, or 10y. How do we get rid of it? We have to do the opposite of multiplication, which is division. We want a 1 in front. How do we get a 1? Well, we have to divide that same number with itself. 10 divided by 10 is that 1, which is what we wanted. We just wanted 1y over here. This is that 1y. Now, whatever we do to one side, we have to do to the other side. I kind of skipped a step, but what is 40 times 1? It's just 40. That's all it is. I'm just going to ignore this right here, because I hope that's clear. Like 40 times 1 is just 40. Anything times a 1 is whatever that number was. So we got 40 divided by 10. What is 40 divided by 10? You enter this in your calculator, or if you already know it, it is 4. So our x, or our y-intercept point is x comma y. But what is our x? 0. What is our y? 4. This is our y-intercept. This is our x-intercept. Let me just show you. Let me zoom out a little bit so you could see the entire thing. This is the equation. Oh, you could see the other one too. Okay, yeah, see. The main idea is we figured out how we figure out the x-intercept. We have to set, or let, another way of saying it, let y equal 0. How do we find the y-intercept? We have to let x equal 0. So when it means by let whatever, or x equals 0, that means every time whenever you see an x in the equation, you replace it with a 0, which is exactly what we did over here. Over here, we let y equal to 0. So every time whenever we see a y, we replace it with a 0, which is exactly what we did right here. There was only one time over here, so we only did it one time. I hope that was clear. Let's do one more. Let's hopefully that this is good. Let's do something different. There's multiple ways to do this, but since I decided, actually, I'm not sure. I might confuse you. You could do it this way. And once you get more comfortable with this distribution, I'm not sure. I'm just gonna do this way to please, or make it more easier to follow and straightforward. Okay. So we need to figure out the x-intercept and y-intercept. How do we figure out our x-intercept? How we figure that out is we let y equals 0. Now, this is our equation. We let y equals 0. So every time whenever we see a y, we replace it with a 0. So we got 4 times the quantity of 10x minus y. What is y? 0. So what is 10x minus 0? It's just 10x. Write down everything again. What is 4 times 10x? That is 40x. There's other ways of doing this, but I'm just gonna write it this way. Okay. Now, we want to get x by itself. How do we get x by itself? We need to get rid of, we need to make sure that there's a 1 in front of an x. Since there's a 40 times x, well, we want this to be just a 1 in front. So how do we make this just a 1? We have to divide by that same number in front of the x, which is 40. So 40 divide by 40. Whatever you do to one side, you have to do to the other side. Why did I divide by 40 on both sides? It's because we want to cancel this number in front and just left with one x, which is just x. Now, what is 24 divided by 40? It's going to be wait, it's going to be 4 times, okay, 6. 10, it's going to be another 3, 5, 3/5, okay. I just did it, or I was like, oh, okay. Yeah, 24 divided by 40. Well, I know that 6 goes into both, or 4 goes into 24 6 times, and I know 4 goes into 40 10 times, which is 6 over 10, which is 3 over 5. Because 2 goes into 6 and 2 goes into 10. So, yeah, you could type this in the calculator. It doesn't matter. Okay, now, our point is x comma y. What is our x? 3/5. What is our y? 0. This is our x-intercept. In order to find the y-intercept, we have to let x equal to 0. I know I'm saying this over and over, but you're going to be doing this by yourself. So every time whenever we see an x, we replace it with a 0. So 4 times 10, or the quantity of 10x, which is just 10 times 0 minus y, equals 24. What is 10 times 0? It's just 0. So we got a negative y. Don't forget that negative. We got 4 times the quantity of negative y, 24. Now, what is 4 times negative y? Well, it's just negative 4y. We didn't do anything to the right side, so we'll just keep bringing it down. Now, we want to get rid of the number in front of the y. Now, we want to get a 1 in front of this y. This is negative 4y. Another way of saying it is negative 4 times y. Now, we want to get rid of the number in front of the y. Now, what is the number in front? I know some of you will just say 4. We want to get the entire, that's not the entire number. It's, the number is negative 4. You have to divide by whatever the number is in front. It's not just 4, it's negative 4. So, since it's a negative 4, we have to divide by negative 4. This will cancel out and become that 1. So whatever we do to one side, we have to do to the other side. Since we divided by negative 4 on this side, we have to divide by negative 4 on this side. Now, we just get y on this side. Let's see, it's going to be 2, 6, yeah, okay. Yeah. That's it. Okay, and now what is 24 divided by negative 4? It will be negative 6. There you go. Okay. You might want to type this in the calculator, but basically, okay, how many times does 4 go into 24 on the top? It goes 6 times. How many times does 4 go into 4? Just 1 time. So it could be 6 over 1. But anything over 1 is just the number in front. But since there's a negative number on one of them, that means it's going to be a negative number. So that's why we have a negative 6. You could type this in your calculator to verify. What is our point? It's x comma y. Okay, it is going to be x is equal to 0, so that's why we set it. X comma, what is our y? Negative 6. So our y-intercept is 0, comma, negative 6. Okay. Now, this is how we do it. We set for the x-intercept, we let y equal to 0. We solve the equation, we solve for x, and we found our x value. Our point is always x comma y, so x goes first, and y goes second. Since our y was 0, we put it in the y. Since our x is 3/5, we gotta put x or the 3/5 here. X comma y, that's how it's done. And same thing over here, when we want to find the y-intercept, we have to let x equal to 0. And then we solve the equation. We got y by itself. Y is equal to negative 6. So we put, for y, we put negative 6. And we put 0 for x, because we told at the very beginning x is equal to 0. I hope that was good. I think I'm going to keep on continuing on with the next one, I guess. This is a little bit longer than I expected, but I'm going pretty slow. Yeah, okay, let me see. Let me get another piece of paper. Sorry, I'm sound a little bit tired. It's 11:46 p.m. So it's a bit late. I wanted to do this video. Okay. Same thing. We're solving for the x and y intercepts, but now we have a different way of looking at it. So the first way we looked at it was a geometric way. Now we have an algebraic way, and then we have another way. We have like a table way of looking at it now, but we could still do this. Let me do that. So, like I said, I'm not going to be doing this example. I'm just going to make up ones right now. The point is to find the x and y intercept. So we're going to be finding patterns through this in order to find this x-intercept. They don't tell you the values, but the ideas are always the same. How to find the x-intercept? You have to you have to let y is equal to 0. In this case, you have to set y equal to 0. For the y-intercept, you have to let x is equal to 0. Now, in this case, we don't see the zeros. How do we let y equal to 0? Well, we're going to have to find a point on here when y is equal to 0. So you see how there's a 2 and then a negative 6? In between 2 and negative 6, there's a 0 in between. So we're going to have to figure out the patterns of the y and the patterns of the x. We're going to have to figure out a way to figure out that point. I will explain in my example. I hope that wasn't so confusing. I will do that right now. Okay. Just moving my papers. Okay, let's do this. Let me write it down. X intercept y y-intercept. You have to let x is equal to, sorry, forgetting letters. This is what happens when you do math at 11:49. Now, okay, let's do an example. I'm going to structure it similarly. Okay, let me make up a problem. Okay. Okay, here's a simple one. Okay. Now, each one of these pairs, if you read it across, this is a point, this is a point, this is a point, this is a point, this is a point. All these side by side are points on a graph, on how we saw. Now, we need to figure out, remember how I wrote down the x-intercept? We have to figure out when x comma 0. We have to find this point when we want to find the x-intercept. For the y-intercept, we have to find when it looks like this, 0 comma y. We have to look on this graph, like this point on like this graph. Now, can you see the pattern that's going on? This is a 2. Let me zoom in a little bit. This is a 2. This is a 4. This is a 6, 8, 10. Now, can you see the pattern? This is 2, 4, 6, 8, 10. Look at what's going up. It's going by 2 every single time, right? Every single time it's going by 2. It's going by increments of 2. Now, on this side, it's going down by 2 because look, 10, 8, 6, 4, 2. It's going down by 2. It's going down by 2. Let me see. Okay. Let me actually write it in pen. Oh yeah, I'm going to be doing it in pens now. Oh, I'm sorry. This is my first time doing it. This. Let me just do this. This is a learning process for me. I guess I'm going to be doing pen now. I guess I have to now. Okay, this is going by increments of 2 on both sides. One is going up, one is going down. And now, we need to figure out when x comma 0. When that happens, then that means we found our x-intercept. When we find the point of 0 comma y, that's when we found our y-intercept. Now, if we were to continue this graph going up and down, can you figure out this the graph and how it looks like? 2, 4, 6, 8, 10. Can you figure out what the next number is going to be? It's going to be a 12, 14, 16, etc. It's going to keep going by 2s. Now, we can go the opposite way, right? We can go 6, 4, 2. It's going to be a 0 above. It's going by 2s. And look, we got our 0. That's going to be a key thing. When x is equal to 0, that means when we found our y-intercept. Now let's do this on the side. It's out of the bound. Okay, now let's see. It is 10, 8, 6, 4, 2, 0, negative 2. This is all going by 2s, right? Negative 4, and it keeps going on forever. Now, going up. Let's do that. That's 6, 8, 10, 12, 14, 16. It's going up by 2 every single time. But look, let me go negative 2 over here, negative 4. Let me be consistent. Oh, it's messy. I didn't plan it. Damn it. Okay. Well, okay. Well, we figured out, look at where we need to find when x comma 0. When does that happen? Okay, look at when x comma 0. So we need to figure out when y is 0. So where's y 0? Right here. What is our x value? Here. So this means we found our x-intercept. We need to figure out the patterns of the table, and then we can find our x and y intercepts. Now, let's find the y-intercept. It's going to be 0, y. That's when we let x is equal to 0. So we need to figure out when x is 0. So it is, boom, right here. That's 0. Our point is 0, 12. That's our point. That's our x, or no, sorry, whoops. That's our y-intercept. Whoops. Let me just write it in the actual way it's supposed to look like, so it looks a little bit more familiar when you write down the answer. That's how you do it. So we got our y-intercept and x-intercept. That's how we do it. Now let's do another problem. Let me think. Okay, we got x, y, okay, 2. Okay. Sorry, I wrote it down. Here's our graph, or a table, not graph. This is a 4. I hope that, yeah, that's better. That's way better than, oh, okay. Yeah, I'm going to be doing pens from now on. Okay. I don't like writing in pen, but we'll just do that. Okay. The idea is still the same. We need to figure out this point because that's our x-intercept. The x-intercept is always x comma y, or x comma 0, my bad. That's our x-intercept, or when our y is equal to 0. And then our y-intercept is when x is equal to 0. So it's 0 comma y. So whatever our y is, it's 0 comma y. That's where we find the y-intercept. Now, let's figure out the patterns. We need to first we need to figure out the pattern of the table. Okay, we're going down by 1, right? From 2 to 1, we're going down by 1. Okay, and then it jumps from negative 1 to negative 2. Okay, let me just hold off on that. Let's see how the other parts go. Okay, now from negative 2 to negative 3, that's a jump from 1, right? Same thing again. So it's going down by negative 1 every single time, going down the list. It's going down by negative 1. Or it's going down by 1. Actually, I should have not wrote that negative, so I just wrote down a 1. But it's going down by 1 every single time. So this jump in here, so that means we're skipping a bunch of points in here. We jumped 3 points. That means that we're going to have 3 points on this side. That's something to think about right now. Okay, now let's figure out the pattern on the y. We're going down by 2 on the y, okay? And then from here, we got the same gap. We have a gap right here. We're going to hold off on this. There's a gap of 6. There's a 6 right here. This gap is 3. There's 3. Because from 1 to negative 2, there's a 3. Or we're going down by 3. And from 8 to 2, you're going down by 6. Now from 2 to 0, you're going down by 2. From 0 to negative 2, you're going by 2. So you see how there's more look at the Don't look at these numbers on the side. Look at the pattern. This is going down by 1. This is going down by 2 every single time. So during this gap, every time whenever we go down by 1 on the x-axis, we go down by 2 on the y-axis. Okay. Now, we need to figure out when x comma 0. So we need to figure out when y is equal to 0. When is y equal to 0? Wait, oh, look. Oh, look. We already got 0. Y is equal to 0. So we already got our x-intercept actually. Right here. This is our x-intercept. We got our x, comma y. What is our y? 0. That's how we find out the y or the x-intercept when we set y equal to 0. Y intercept. Oops. I kind of went off track. Sorry about that. So, that's how we do that. Now we figured out our x-intercept. That was easy. We just figured out because it was 0. There we go. Now we need to figure out our y-intercept. Our y-intercept is when we find when x is equal to 0. When is x equal to 0? Okay, we gotta figure out y. Okay. Look how, okay, you see there's 1 and then negative 2. Okay, on the number line, 1, there. 1 and negative 2, there's our 0. We're going down by 1. And you see how every time whenever on this side we go down by 1? Well, on this side, every time whenever we go down by 1, or we're going down by 2. So we go down by 1, down by 2. So that means from 1 to 0, that's 1. I'm going to put on the side. I'm going to put it in between. So we're going down by 1. I'm just moving this 8 on this side. And then, okay, imagine we ignore this part on the right here. We got 1, 8 right there. 1, 8. Now, we go down by 1 on the x-axis. On the y-axis, we go down by 2 every single time. So since we go down by 2, what is 2 down from 8? 6. There's our point. 0, comma 6. Our x and our y. So when x is equal to 0, y is equal to 6. This is our y intercept. There you go. The point is for this table is to find, or for the x-intercept, because the whole point that we're trying to do is find the x and y intercept. How do we find the x-intercept? Is when y is equal to 0. And then how do we find that y-intercept? We have to set or let x is equal to 0. That's exactly what we did. Y-intercept is 0, comma y. What is our y? Our 0, comma 6. That's our y. And that's exactly how it's the same format. Same idea. Let's try something else. Let's do, trying to think. Negative, let's do this. This is our graph, or table. I keep saying graph, table. Okay. What is our idea? To find, or what's our goal? we're trying to find the X and Y intercept. And it's points. And that's how we find them. It's a specific point. Now, how do we find the X-intercept? We have to find when Y is equal to 0. So we need when Y is equal to 0, and we know our X. That's our X-intercept. When X is equal to 0, we found our Y-intercept because our Y-intercept is 0, comma Y. So we need to find the pattern of this graph. Okay, we're going down by 1, and right here we went down by 2. Whoa, well, that's something there. Over here, we went down by 2. So there's something going on right here. Let me think. Okay, yeah. And right here, we're going down by 3. This one, we're going down. We went down from 5 to -1. We went down to 6. Well, okay, that's a jump. Okay. And then from -1, we went to -10. So that's another jump. That's a 9 right there. That's a 9 jump. This is a little bit more complicated. I tried to make it a little bit more complicated. Okay, from -10 to -16. Okay, well, we got a 6 drop. Okay, now I want you to notice a pattern. You see right here, we went down 1, and then we on the x-axis, and we went down by 3. Over here, we went down by 2, and then we went down by 6. So that means every time whenever we go, and then over here, the same thing. We went down, or we went up, or not, or down. We went up, now down. Whoops. It's 12:07. Sorry. We're going up by, okay, from -4 to -3, we went up 1. And then from -3 to -1, we went up by 2. And then from -1 to 2, we went up by 3. Now from -2 to 4, we went up by 2. But look at, we went up by 2, and we went down by 6 over here. So we went up by 2, down by 6. So it seems like this is true. So every time whenever we go up by 1 on the x-axis, or +1, or adding 1, we subtract 3 on the y-axis. Does that make sense? So we added 1 on the x, which is, you're adding 1 to -4, which is -3, and then we subtract 3 from 8, which is 5. So that seems like we're doing it correctly. So from how do we get, let's first figure out the x-intercept. So we need to figure, or actually let's do oh no. I think I'm gonna make it complicated. Ooh. Oh man, I made it complicated. Okay, let's find the y-intercept. Okay, well, we want to find when when the x is equal to 0. Okay, you see how there's a -1 and then a 2. So that means that there's a 0 in between here. I'm gonna put -1, and then over here is -1. And then we want 0. Okay, we went down. We went up by 1, so that means we have to go down by 3 because that's our pattern. So we're going down by 3. What's going down? Let me actually draw the number line. 1, 2. We went there. -2, -3. -4. So we're going down by 3. 1, 2, 3. So our y value is -4. This is our point. This is our y-intercept. Why is it our y-intercept? Is because x is equal to 0. So let me just put it in point form. Okay. Now, I think I made a mistake. I think I made it a little bit more complicated. Oh man, I made it more complicated. Yeah. It's gonna be a fraction. Yeah. Okay. Uh, so. Okay, look at it like this. For the x-axis, I guess this is the harder question. Uh, okay, look at it like this. Every time whenever we add 1 to um, the x, we go down by 3. Sorry, I'm tired. It's a little bit hard to focus right now. Yeah, every time whenever we go up by 1, we go down by 3. Now, so that means, okay, we are y. If we want to go up on the y-axis, go the opposite way. So that means we're going down on the x-axis. So we're going in this direction. Since we're going in this direction on the y, because we want to figure out when y is equal to 0. Because -1 and 5 is in between each other. Or, yeah, no, 0 is in between -1 and 5. So it's in between right here. So our number is in between here. This right here. So this is where our point is. Now, since we're going up or going down by 3, every time whenever we go up by 1, we go on the y-axis, we go down by -3. So since we want to go up on the y-axis, that means we have to go down on the x-axis. Oh, whoops, I was so off. Yeah, okay, just let me explain it again. Okay, so every time whenever we go up by 1, plus 1 on the x-axis, we go down by -3 on the y-axis. Now, since we want to go up, because we want to go to that 0 point, which is just 1 up from -1, so we want to go up 1. But we can't just go up. Our ratio is 1 to 3. So every time whenever we move up by 1 on the x-axis, we go down by 3. So we're reversing it. So if we want to go, say if we were to do the complete opposite, say that if we want to go up on the y-axis, 3. So that means we're going down on the x-axis, -1. Does that make sense? But we're not going 3 up. We're going only 1 out of that 3. Another way to look at it is 1/3 of it. So we're going 1/3 of the x. Because I believe that's how I can explain. I'm not sure how else I would say explain it, but okay. This is an entire piece, and this is an entire piece. These are equivalent. If you only go 1/3 of this, you only get 1/3 of this. So 1/3 of 3 is 1, which is what we wanted to do. We wanted to go, or we got the notation right. So we got to get 1/3 of -1. So what is 1/3 of -1? just -1/3. So that means we have -1, and then we have to go down another -1/3. So that will be, imagine you have a full pie, and then you have a third of a pie. How many pieces of a third of a pie do you have? Well, if you were to split that pie into 3 parts, you would have 3 parts. And then, okay, well, you have another third, 1/3, so that means that you have 4 thirds. So this x will be -4 thirds. This is what I meant. I chose a bad example, but the x will be -4 thirds, and then your y is 0 because that's what we wanted to do. We wanted to go up by 1. And then for the y-axis, whenever we go up by 1, we have to go down on the x-axis 1/3. I hope I made that clear. I should have chose a different example, but that is how it would be. If you could do this problem, you could definitely do the questions on this worksheet, definitely. So that's how we do it. I'm just gonna stop it right there. I did a lot of explanations for this. I hope that was clear. Now, let me just explain. Let me go back to, let's see if I have papers. Okay, let's do the graphs. You know how I said set y is equal to 0 in order to find the x-intercept, and then I kept saying to find the y-intercept, you have to let x equal to 0. Well, the reason why we're doing that, and I kept repeating it over and over, is to deal with the x-axis and the y-axis. We have the y-axis. What is the value of the x? What is the value of x when it's on the y-axis? It is 0. That's exactly what we did. We let x is equal to 0. The reason why is because on the y-axis, x is equal to 0. And then same thing for the x-intercept. Why did I keep saying that we have to let y equal to 0? Is because the value of y on the x-axis is 0 because there's no positive y or negative y. It's neither. It's on the floor. You could look at it like that. It's not going up or down. It's perfectly leveled with the floor. That's why I kept saying to find the x-intercept, you have to let y equal to 0. So this entire thing was about finding the x and y intercept, and in order to find the x-intercept, we have to let y equal to 0. Let me just write down, because we put x comma y. That's how we do our point. X comma y. We don't know what our x is, but we know what our y is at the x-intercept. It's 0. You let y equal to 0. Same thing with the y-intercept. We do not know what our y is, so we just leave it as y. But we know what our x is. X is 0 because on the y-axis, x is 0. And then on the x-intercept, y is 0 because there's no up or down or height associated with it. Same logic to it. I hope that is clear. I was going kind of slow, sorry about that, but I hope I did a lot of explanation. If you need more help, just leave it in the comments below. I hope you enjoyed it. I'm just gonna zoom out a little bit so you can get a a little preview of the entire thing. Let's see. This is for the first part. This is what we did, how we did it. I just drew some random graphs, told you some facts. And on this one, I did the equations. And then I did some on the back. I did a lot. I hope this is clear. You can pause the video at any time. Let me show you this. I hope this is clear. This one was a bad example because you have to do a little bit more thinking about it. It's not as straightforward as the first two, but I think it's good to do a little challenge. But yeah, I hope you enjoy it. Thank you again for watching.